Welcome viewers, welcome to the SD online classes. Here we are doing today class 10 physics of MBSc Mizoram Board of School Education chapter 1. The name of the chapter is light, reflection and refraction. This is from your textbook page number 17 onwards. Okay, till here we have finished the first part of the light reflection. We have finished. We did some numericals as well. Now for your refraction, you have to know first what is refraction. Okay, in order to know that, I'll first write its definition and then I'll explain you what is the refraction actually is. This is the definition. Look at here, the phenomenon is the whole process. The thing that happens is called phenomenon of bending of light. Bending means, suppose your light is going in one direction, straight line, and suddenly it changes directions, going here, suddenly it changes. That is called bending of the change in direction of light rays when it comes, not just bending of any other type, bending when it comes, when it travels from one medium to the other. The medium may be first water to the glass, maybe from air to the glass, like that. Okay, whenever it changes the medium, suppose your light is in the air and suddenly it goes pass into the, it is going passing into the other medium and it is changing its direction. Very simple example I will make here. Suppose this is a simple glass slab, okay, just like any other material, glass. Your light is entering here in this direction and it is passing directly here straight. That is called no bending. But suppose it happens that light is bending slightly like this. This here, can you see this bending happen? So that is called refraction. Okay, remember the refraction spelling is FRACT. Whereas reflection was different. Reflection was bouncing back of the light. It has to have one like this, see, hitting here and coming back. This is called reflection. This is called refraction. In the refraction, it has to go inside it. Okay, so here medium is air, here the medium is glass. Okay, if it comes out from here, this will again bend it like this, from water, glass to air again. There also it will not pass here. Okay, so it has supposed to go like this, right? It was supposed to go like this, but it changes direction. It is supposed to go like this, but it changed its direction again. Can you understand? Okay, this is called refraction, the bending of light. The changing of direction is called refraction. Okay, now what is the cause, what is the reason of this refraction, why this happens? Very easy to understand this. Why this happens is because there is a change in the velocity of the light. Because the light has to travel from here to here, it will take some time, and in this medium light speed will decrease. In the glass, light speed is little bit, just like you are running in the air, on open air it is very easy, but when you enter inside the water, swimming pool, and then you run, it is difficult. Just like that for light also, here moving and inside the glass moving or inside the water moving is slightly difficult, slightly it will take more time. So the speed will change, velocity will change. So because of that change, refraction is the bending of light is happening. Okay, let's write it. So you see here the change in direction. Why this is changing its direction? Because is due to the change in velocity of the light, because the speed of the light, the velocity with which the light travels is different in different medium. In air it is different, in glass it is different, in water it will be different. So how it is different? The velocity of light in rarer medium, rarer is the lighter one, which is less, just like it is also called low optical density. For here it is air is the rarer medium, glass is the denser medium. Okay, it will depend on both of them. If it is glass with water, it will be different, like air and water it will be different, like that. Okay, and similarly the velocity of light in a rarer medium is more, because in air like it will be very easy, so the velocity will be more high. The velocity of light in a denser medium, okay, denser medium, just like glass, here it will be high optical density, so the velocity will be less, and because of that reason you will see that the the light rays will be bending inside whenever there is change in the medium. Now, how it is different, how much? For example, I take air and water. For example, air and water, just like this example, velocity of light in the water will be slower, 2.25 into 10 to power 6 meter per second, very slow compared to this one. In the open air, velocity of light is its full speed, 3 into 10 to power 8 meter per second. You can see there is a difference of the power also. Two digits 100 and 100 digit difference is there. So, it is very fast in air and slightly less faster in water, and that is the reason of refraction. Okay, that you have to, you did not need not remember the value of this. This is the well known value, but you have to know that whenever you are in the denser or rarer medium, the velocity changes, because of that refraction happens. Okay. Here we need to know a very small confusion, but it is easy. Optical density will decide which is rarer medium and which is the denser medium. Okay, it is not same as mass density. You know that cotton is very less density, the iron is high density, like that you can easily know. But in the optical density case, you cannot know like that. Okay, it is like the kerosene is, its mass density is less when compared to water, because if you mix kerosene and water, what will happen? The kerosene will come on the top, water will be down. That means its density is less. But optical density, inside it, the way the light travels will be slower in kerosene. Okay, so its kerosene is optically more denser than water. Similarly, turpentine oil also, alcohol also, like that. Okay, though they are lighter, mass density is less, but their optical density is more. So, you cannot directly decide that looking at them they will have more or less optical density. Okay, but usually they are optically density more easy, like air and water. You can easily say water is more optically denser, glass is more optically denser than air, like that. Okay, so these are the simple things. So optical density has some meaning, you need to know that. Okay, simply don't say that density is more or density, optical density is the correct term to use. Okay, till now I have said that there will be bending whenever you change the medium. Okay, we know that whenever air is passing through the whenever light is passing through air to the glass, there will be bending. You have seen that it should have gone like this, but it has gone up here, and here also it should have gone like this, it has gone like this. So, you know that it is, there is something like bending of light, which is called refraction. But now how much it will refract and which side it should be bending, okay, that we will be doing this in this characteristics of refraction of light. Rules that the bending of light follows are, what are they? Number one, with diagram it will be very easy. Some terms are there which you need to know in refraction as well. So, let me make the diagram first and then I will write them. Okay, in order to understand these rules, first of all let me make one medium here. Medium is, maybe it is glass. Okay, this is the denser one, optically denser. This side is optically rarer, maybe air and glass. This is air, this is glass. Okay, now we have to make the light coming from the rarer medium. Suppose this is the light coming from here, this is the light coming from here. Okay, and this line is important, which is there in the dotted line. This is called normal. Wherever in the surface you have a perpendicular, that is called normal. This is perpendicular, that is acting as, this will work as to measure the angle, how much it is incident angle. This is the incident. Even in the reflection also this was true. Now, if there is no denser medium here, the light would have gone like this. This is the way to go, but it will not go like that. It will go close to this normal. Can you see? Close to this normal means towards the normal. It has gone towards the normal. Towards means in the side of the normal. This side is the normal, this line is the normal. Okay, this line is your normal, and the light has gone towards the normal. So, this is a rule. This is itself a rule. Whenever light travels from rarer to denser medium, it will bend towards the normal, you have to know. So, that is why light has come from that side to this side. Why? Because the normal is this line, n is the normal side. So that much, okay. This is called R, the refracted light, you can say. I, you can call it is the incident light, I. This is incident angle, and the angle is also measured with the normal is always acting for measuring. This is called a refracted angle, R, refracted angle, okay. This is the process, and the opposite also true. That will be the second part. In detail, it is like this: a ray of light, this is the ray of light, passing obliquely, obliquely means making some angle, from an optically rarer medium, this side is the optically rarer medium, the air, to an optically denser medium, this is the optically denser medium, maybe glass, bends, see bending happens here, it is coming, this light is coming from here and it is bending this side, from here to here it is bending this side to my side towards the normal, because this is the normal line, it has bent towards the normal side. Here you have to see in a simple way, angle of incidence is I, it has become smaller, R. So I is less than R is whenever it is coming from rarer to the denser medium, okay. In the second one, we will make the diagram first, okay. In the second one, what we do is, in the diagram, look at here, this is the denser medium first and this is the normal line, okay, normal line. Suppose this is the incident light, this is the incident light, some angle is made, how much? I is made, okay. Now it is going from denser medium, this is denser medium, to the rarer medium air, this side glass, this side air. What happens if you remember the previous one, exactly opposite, here it will bend away from the normal, it should have gone like this, if nothing is there it will go like this, it should go like this, but it will not do like this. When from denser to rarer, it will bend away from the normal, opposite to number 1, okay. In that case it was coming here, in this case it will go here. So now let us see what happened. Incident angle, this is the refracted angle, can you see R is very big, so that is the only difference, that much you have to know. Two rules, very important. In the statement, look at here, a ray of light passing obliquely from an optically denser medium, this is the optically denser medium, a ray of light, a ray of light, a ray of light, a ray of light passing through obliquely denser medium to means from this side, an optically rarer medium, when it is going, it bends where it is not, it is should have gone here, but it is bending away from it, this normal, okay. This is normal and it is bending away from it, this is normal n, this line is normal, and it is not coming, this side, it is going that side. So this is the away from the normal, here bends towards the normal, to the side of the normal, towards means near to the normal, away means far from the normal. So this is the normal, far, and here you see angle I is less than angle R, R has become very big, you measure it from the end, this is R, refracted angle is big here, in refracted angle was less here. This is all in the 2 of the statement. There is this third rule, it says that in the third rule, what is there, you have two denser medium, suppose separately I will give two examples, okay. Third one, this is the denser one, okay, this is the rarer one, air, here this is the rarer one, this is the denser one. Suppose the light is coming from the rarer medium, denser, rarer. Suppose light is coming from the rarer medium like this, but it is accidentally exactly on the normal, okay, this is the normal, you remember normal line. If it is coming from there, that means there is no angle between incident, that time what will happen, there is no bending, it will not go here, it will not go here, it will directly pass like this, okay. So this is the third rule, it passes through it. If a ray of light passing normally, it will pass directly, nothing will happen to it. If, what will happen, here you look at here, when a light passes from here, see, optically denser medium to the rarer, here also same thing, if it is passing from here, it will pass directly here, Okay, same thing in the both. You can passing optically rarer medium to denser medium, passing from optically denser medium to the rarer medium, also the same thing. Okay, that we'll write in the statement. It is simple. So in the statement you read it, it's interesting. A ray of light passing normally means 90 degree. Here can you see 90 degree, 90 degree here also. If it is passing 90 degree right angle from one optical rarer to denser or denser to rarer medium to another optical medium does not bend, nothing will happen, just it will pass. Does not bend means no change in the I and R, both are equal to 0, because here you see between this line and the normal n there is no difference, same line with the same normal 0 angle, and here after refraction also same normal same refraction angle 0 degree, both are equal. Remember in the first one incident angle was more, I is greater than R, in the second one I is less than R, in the third one, this third rule, I is equal to R is 0 degree. So these are the three things you need to know in the characteristics of refraction of light.